All right, so now the last video of this section is just going to be about changing the base. So remember, our calculators are always in base 10. So if we were trying to do log base 3 of 5, we can't use our calculator right now to solve for it. Now, we can manipulate our calculator, and some calculators does allow you to change your base, but if you just have a regular standard basic addition, you're not going to be able to, right? So this is how we can go ahead and change our base so that way we can still plug this into our calculator. So one way that we can do this is that we can try and rewrite these with the same base. So our base, what our base used to be, log base b of m. So this m is going to go in our numerator, and this base b is going to go with our denominator. Now, we create a different base. There's two ways that we're going to do this. One is we're going to do it by hand, and then the second one we'll do it with the calculator after. All right, so there's a couple problems that we're going to do. But you got to remember that whatever your base was, you're now dividing by that. And whatever your base, like how it's log base b of m, that would then be your numerator. Right, so your base is always going to go into your denominator. So let's just do a couple problems. The first one we're going to do by hand. So we're going to rewrite this. So we know it's going to be log of 27 over log of 81. But we need to rewrite and create a base. So since 27 can be rewritten as 3 to the third power, and 81 can be rewritten as 3 to the fourth power, they're both 3 raised to some power. If we want to do this by hand, we can go ahead and just change these to log base 3s. And the reason why we would do that is, if you remember in the last video, we can then rewrite this as log base 3 of 3 cubed over log base 3 of 3 to the fourth power. And since we have an exponential equation with the base 3 and a logarithm with the base 3, we know that they will just cancel or undo each other, and this would then be equal to 3 over 4. All right, so that's solving this without using a calculator. So if you can manipulate your numbers and rewrite them as the same number raised to a base, especially if they're both able to be written as some number raised to a power. If you don't want to do it by hand, you can just use a calculator, and whenever you use your logarithm button in a calculator, it's automatically understood it's going to be a base 10. So you could just rewrite it as log of 27 divided by log of 3, and if you type that into your calculator, it will use base 10. Remember, when no base is written, it's automatically understood to be 10, and it will give you the answer of 0.75, which is equal to 3/4. Right, so using your calculator, you can just rewrite them as base 10s. If you want to do it by hand, then you try and ask yourself, can I rewrite these numbers as the same number raised to a power? And since 27 could be rewritten as 3 cubed and 81 could be rewritten as 3 to the fourth, I knew that meant that my base for my new logarithm had to be 3. And that way I could cancel out my logs and my exponential and just get the answer of 3 over 4. All right, we're going to do one more problem. This one, we have log base 5 of 36. Well, I can't write 36 and 5 as some number, so some base raised to a power. We can't do that. They can't be written with the same base, or if they, when they can, we can't do it mentally. So this one is forcing us to use our calculator. So we would do log of 36 divided by log of 5. And when you type this into your calculator, it will give you back 2.22656 ... So we would just go ahead and say that this is approximately equal to 2.23. Or depending on what we were doing, you can always just use the answer button if you're actually using this to solve a problem. So that way you're getting the most exact answer possible. But just if I was asking you to what is the value of this expression, you can just rewrite it as 2.23, or just follow the directions for where they ask you to round it. All right, that's it for this video, and that's it for this section.